Welcome, everyone. Thank you for joining us for today's webinar. My name is Agatha Walker, and I'm the Marketing Manager at InVMA, and will be your hostess for the next 60 minutes. Before we begin, I'd like to encourage you to type your questions into the question box in your control panel, so we can answer them at the end of the session. Also, we are recording this webinar, so the copy will be sent to you in a follow-up email. Today's webinar is IoT Exposing the Hidden Factory, and what we're trying to achieve today is to consolidate what you already know about the hidden factory, to help you understand the technologies that are exposing the hidden factory, and help you learn from experiences using this technology, and also consider some of the adoption challenges for your own situation. Now is the time to introduce our presenters. We are very lucky to have Stephen Bromley, Chief Executive at Gambia. For those of you who don't know, Gambia is the Association of Instrumentation, Control, Automation, and Lab Technology. We also have John Hill, who's the Business Development Director at InVMA, who's a Digital Transformation Partner. So without further ado, it's over to you, John.
Thanks very much, Agatha. So Steve, would you like to tell us about Gambia?
Yes, certainly. Thank you, John. So Gambia is a trade association. We represent industry to the outside world, and we do three main things. We provide knowledge to our members, we provide influence on behalf of our members, and we provide a community. Our focus is on four main sectors. It's industrial automation, process instrumentation and control, test and measurement, and laboratory technology.
Thanks, Steve. So InVMA, we're the digital innovation partner. We help people who are going through the Industry 4.0 transformation to deliver what they're trying to achieve. We have an end-to-end capability based on an industrial heritage, and we lean heavily on our partner ecosystem to help deliver the transformational change. And we do this right from the point of answering the question why, to the how, to the who, to when, to the when. And then obviously we look after you after that. That's InVMA overall. We're here because of the fourth industrial revolution. We're witnessing around us a profound shift in all industries, marked really by the emergence of new business models, the disruption of incumbents, and the reshaping of production, consumption, and transportation. This is the fourth industrial revolution as described by Klaus Schwab, the chairman of the World Economic Forum. But specifically today, we're going to go into the hidden factory and look at some real issues around the hidden factory, and then we're going to bring it back up to ask about how this can be addressed at a more national and local and SME level. So first of all, what is the hidden factory? Well, simply the hidden factory is a description of the activities that reduce the quality and efficiency of a manufacturing operation or business process that initially aren't known to managers or others seeking to improve them. So for the Six Sigma and similar initiatives, this focus is on identifying these hidden factory activities that are actually costing you time, money, or indeed quality. So when we look across a factory, the opportunities that we see with exposing these processes are in the areas of OEE, with scrap, with energy, with getting things right first time, looking at yield, waste, work in progress, rework. All of these sort of things have a significant influence on the performance of the factory, but it's surfacing that data that we're going to be talking about today. There's also elements as well around maintenance and non-compliance, which obviously affect those overall measurements. But it's not just about within the factory nowadays, as we're getting shorter supply chains, shorter product life cycles. Other data elements start to come into play to help support and understand what's driving waste and rework in the factory. Some of these are from big data, from social, environmental or economic areas. Some are from suppliers, from the supply chain, just so we know, for example, delivery schedules, where the delivery is, right the way through to the outbound on deliveries, and also on demand management and understanding what demand is going to be. So that's sort of on the process side, but also there's a knowledge side, which is looking at across factories, what is the best practice, comparing performance between factories and production facilities, reliability, but also doing vendor analysis. How are different machine types or vendor types performing in your factory, and looking across that. And this is all really to improve. We need to expose the hidden factory, because to improve we can use something like the Deming cycle, excuse me, which has been around for well over 60 years now. And the Deming cycle really takes you through the plan, do, check, act approach. And really you plan ahead, you execute that plan, you check, and then you act on what you've learned as you've gone through that cycle, replan, and keep continually going around that improvement loop. But this takes your people to be able to be empowered to take decisions to help and do the improvements. And you want them focused on the most important things first to do the improvements. So you need some data. But underlying all of this is that you need a culture which enables teams to use data to take action. So what's the barriers? What sort of things are getting in the way of this? Are some of the systems that we've got in place have been layered around some core architectures. Indeed, the ISA 95 model describes these different levels of systems and process and data. Aimed at the process level, looking at control level and data acquisition, yes, absolutely, the manufacturing process itself. The level 2 above, monitoring those processes using the HMI, the SCADA, etc., looking at, or SCADA, looking at those and managing the machines in the layers below. Then there's the MES, which is looking at managing material flows into and out of the factory, the whole management of the factory and the stocking process, etc. And then the ERP and the CAD, which goes right into ordering the systems, indeed in some cases managing bill of materials, etc., and what is actually getting built in the factory. So these sort of 5 levels, going from 0 to 4 of data. The issue is these have all been designed around process. They're all from process re-engineering days when we're really focused on process, which is the right thing to do. But there's another dimension you need to consider, which is the individuals that are working across these processes. So if I take one example here, there's a maintenance person. If he or she is going to look and schedule some maintenance for a particular item on the line, then it would be necessary for them to understand potentially what is the current schedule, when is the next changeover due, what is the product that's going to be going down the line, and whether there's alternatives machines to be used with that particular product, as well as when they actually get to the machine, dealing with work instructions or data on how to service the machine, specifications around tolerances or indeed torques on particular items of the machine. So that the point I'm trying to make here is that as an individual, I would need access to and go across all of these different systems, whether that's look at production, quality, inventory, maintenance, or indeed energy, to look across the different systems. And these systems, the issue is as well is that at each layer, there actually may be different systems themselves within there. So for example, at the 0 layer, you might have different PLC controllers talking to different SCADA, different MES we've seen in separate factories as well, with even individual lines are running separate MES systems. And all this is because, as technology has moved on, as factories and procurement teams and the engineers have bought into new technology, they're picking up the best for breed as they proceed. So what we normally see when we go into factories is around that then people put in a lot of Access and a lot of Excel as they try to stitch together, glue together this data to give the users the view across the system landscape, across those different verticals. So that's the situation they're in. But what are the technologies that are coming? And really the key technologies around Industry 4 and around what is called the Internet of Things are really starting to bring together these two worlds of the physical world and the digital world. In manufacturing, we've been used to machine, we've been used to communication and networking on machines, maybe up for some people up to 20 years now. So we've been used to the physical getting into the digital world, but now we're starting to see this return of the digital getting back into the physical. And we're seeing that in the world around us. The products are changing. Products themselves are getting connected, whether it's connected car to a connected fridge or even to Alexa. we're starting to see that products are changing in the way that they're being presented and sold. Operations are becoming more efficient with M2M. We're starting to see smart operations, but also this move to a systems of systems where, instead of it all going to a central control point, individual assets are talking to each other to optimize the process from within without going to a central control. We're also seeing service transforming, where people are able to remotely get access into the machines to do remote diagnosis and understand how a machine is currently performing, and even diagnose problems so that repair and maintenance can go with the correct parts to site. Right the way through to here, where we're starting to see people using augmented reality to indicate what service steps actually are, so that someone who's not as trained or as skilled can actually undertake this service. So service is transforming as well in the real world. And how we interact with things is changing. That's happening more and more. People are getting used to interacting with Alexa for voice activation and help. People are starting to get used to seeing data in screens, and also eyewear is becoming available now, which enables you to see data displayed over the real world. So understanding all this industrial digital innovation is quite challenging. There's 3 great articles out there that we just want to bring your attention to. They're written by Jim Heppelman, who's the CEO of PTC, and Professor Michael Porter, he of the Porter's 540s fame, from marketing professor, who have come together and written 3 very good articles, we believe, in the Harvard Business Review, that explains some of the impacts of what smart connected products are having on competition, on the companies, but then also they extend that into augmented reality as well. So you start to see the implication of all these sort of industrial 4.0 technologies on business. So we've put in here on the download, you can download these HPR articles. Please feel free to click on that and download and review them. So what happens at the moment is that we're all used to, as the digital and physical worlds come together at the moment, we're used to sort of seeing the world as the physical world. Take the picture on the left here with driving the car. And then we're interpreting the digital world. And really what we've been doing so far is we've been digitizing paper. We've been taking a paper view of the world, making it digital and making it move. And that's great, but what it means is I have to go through a cognitive step of translating what I'm seeing on the right to what I'm seeing on the left. Yeah. Now, what's happening is as the physical and digital world are coming together, we've got to move down. If you look at on the one side, where data is going from the physical to the digital through the Internet of Things, so things telling us how they're performing and are storing data about those things. But now we can present data back. We can do work on that data. We can interpret it, and we can present it back to the user in a way that they are most programmed. Through evolution, we are programmed to process a lot of visual data very quickly if we're used to seeing it. So in the context of the car, if I take that ahead, much better that I present to you the fact that this is the right turn that we're doing and overlay where the car is going to go. That's much lower cognitive challenge for me to be able to take the right decision, as if it was to even the turn right now, this right or the next right, I'm not really sure. So what we're doing here is we're getting a human converged experience, which is the physical and the digital worlds coming together. So if I wrap this all up, is that really what we're saying is, look, technology is advancing in the area of connection, low power radio, and how we connect to the physical world. We're getting a combination of IT and OT, operational technology, and information technology are converging. So we're starting to be able to understand context and bring context to the operational world. We're getting a lot of tools now around analyzing the digital data. And also there's a lot of tools out there for orchestrating the response, so that, what are we going to do when we understand something or we've discovered something. But also, as we've just seen in the car example, we've got tools now that can engage people using the digital actually on the physical to make all of this a lot more straightforward. And what this means is how could I use then this new technology to wrap and extend what I've currently got? Now, you've all got a significant investment in the machinery, the infrastructure and the equipment that we've got in a plant. And, we've learned, certainly through the 1990s, that the idea of rip and replace is quite an expensive way of approaching some of these solutions. So really what you're looking for is an industrial innovation platform that complements and brings unified visibility across your systems, assets, devices, and people. It enables you to sort of wrap and extend the existing systems to provide you with actionable and comprehensive operational intelligence that is, yes, real-time, social, and mobile. And the other thing that we really need is that if we're going to do this and wrap it to present the data in a very simple way, is that each factory and each user or each role is different depending on where you are. So you need to be able to configure and change this in the same way as you can change a PowerPoint presentation. So, a rapid application development. So I can build these apps to present this data to people as simply as if I was building PowerPoint. So what we're trying to say here is look for an industrial innovation platform that's going to help you enable this. You need something that enables you to source data. That data from the machines itself across all of your protocols, right up to from your ERP system to get context, or indeed your CAD system for your product designs if you're using AR for assembly instructions, for example. By bringing that data together, it allows you to contextualize. So the user doesn't have to go and search for the part number. They know that they're working on this machine and these are the available part numbers for you. And these are the available parts, and this is what they look like, so they can pick what the part looks like and not what the part number is. That you can start to then take data and synthesize it, which means that you can take some of the, so for example, how the machine's been running over the last 6 months, and then using that to predict failure, if you've got some failure modes, to predict time to runtime failure, time to next service, etc. is one example of some simulation. Then there's the issue around orchestrating, which means actually get people and things to do work. So this could be orchestrate to trigger work in other systems. For example, you could have it set up so that when you notice an alarm on a machine, rather than it having a red light that flashes waiting for someone to notice it, and on the SCADA have a red light, it actually triggers workflow and triggers work into the works order system to prioritize for a maintenance team to go out and gets into their work stack. So that's the orchestrate. But finally, all of this needs some engagement with a human for them to be able to be engaged to help, to resolve the problems or indeed take advantage of the opportunities. And so you need to engage them through something like desktop or a laptop, mobile, and indeed these wearables, which where you can experience them in a way that enables you to use the information in a brains-on, hands-free way, so you're not having to carry paper around with you. So that's really what's the crux of an industrial innovation platform. How do I get data? How do I know and understand what this data is really telling me, the so what question? Can I run some analysis to tell me what that might mean in the future? And then do I trigger work? And can I do this in a very easy way that suits my role and what I do in the organization? So what about the experience of others? So very fortunate, we had an event at the Advanced Manufacturing Research Centre a few weeks ago, where very kindly Dr. Billy Milligan from Howden Compressors and Alan Finlow from DMS presented, and I'm just going to present here a short, brief overview of what they presented to us there. So just going to take you through that now. So the first case study is with Howden. Howden are a manufacturer of compressors. They've been in business for over 160 years, based in Scotland, in Glasgow, as their global base, and they provide support to many industries, from process industries right the way through to oil and gas, from different size of compressor packages, from large bespoke packages for oil and gas, right the way through to sort of simple blowers and other installations. So these are so if you'd like, this is what, as Dr. Milligan described, is in front there, Billy. This is what they do, and this gives some scale. That's a picture of Billy himself actually in front of one of their packages that they sent. This is what they do and have been doing for the last 160 years. So why were they discussing digital transformation? Well, clearly there's a movement to there's a global uptake of the digitization trend. So other people are doing it. So how should or could we get involved with this? But really, the real reason, the real crux is that the world is moving from this idea of I sell a product and then I move on to the next person to sell my product, to my product becoming more and more like a service. So you go from just selling the capital product and maybe a little bit of service or some spare parts in the future, to actually helping the customer solve the real problem that they bought your capital equipment for in the first place. Now, Howden's not a big data organization, but they are committed to leveraging the data around their operations and equipment to enhance the customer value through added services around that, around their equipment, to optimize their operations, and through that create a new business model. So where did they start? So they started with, look, we've got 160 years of experience in designing and manufacturing rotating equipment. Yeah, so they've been designing these things and they understand how they work, and they can model theoretical performance and compare it into the field. If they connect to machines, they can work with all the industrial connectivity protocols, and they can integrate now with all the existing control logics, etc. So they can now connect to the machines. They store the data in Microsoft Azure, so they can store the data, so they can start to get history, which does a couple of things for them. It enables them to provide advice, as we'll come on to in a second, for their customers, but also helps them optimize their own designs to improve the performance to the customer. Analytics, which enables them to run this large amounts of data that they're starting to get together and then get from it insight, which helps them provide services to the customers. And then getting to a point now where they can give a service which is the full customer solution around what they're calling their digital twin. So what they're doing is they're building on providing that digital twin that we talked about. They're using artificial intelligence and machine learning and augmented reality to provide expert guidance for the customers to create the most value. Well, what does that mean? So where they are currently, they can help customers who've got potentially a complex customer need. But actually, a lot of the reason behind the name of uptime is that they can help the customers avoid unplanned downtime around what are critical assets, particularly in oil and gas, and that's worth something to the customer. And also they can guide and help the customer in the usage and the control strategies that are used around their assets to make sure they operate close to the best efficiency point, to avoid Howden equipment operating away from the best efficiency point. And then as a future, they're going to be moving into more predictive maintenance, which means that you move away from scheduled maintenance and you move to predictive, and which means that very much like your BMW car or your Mercedes or many cars nowadays, where they tell you the time to next service based on the way that you're using your car. Similar idea for the way that you're using your compressor set. But also, again, providing advice about performance optimization on demand around the customer's equipment. But interestingly for Howden, also providing a direct link to service and support. So whereas it would have required an engineer to visit, for example, Howden can see and get into and start to do remote diagnosis on those machines if there is a potential problem, but also be proactive in that they can have parts, etc., available to perform the planned maintenance. So it remains planned rather than becoming unplanned. And also they've got quite a few other things that they're considering, some of which we won't go into here. So really the messages from Howden is, look, 160-year-old company used to producing rotating equipment is now using data to provide value-added services and wrappers, because actually people want what the compressor does and they want it to be doing it all the time rather than just a compressor. And that's really what they can now offer. So that's why now they're the heart of the operations. If I move on to drive management services, so Alan Finlow gave this presentation, the MD of DMS. Really, drive management services are engineering reliability specialists, and they specialize in diagnosing problems with equipment and monitoring the status of equipment so that they can avoid, again, unplanned downtime, but also can give the engineers on site an indication of what is going wrong with their product so they can get ready for doing a planned replacement. Because there's an important fact that they really point on. there's really their numbers are they understand that a 10% saving in maintenance costs in some cases is equivalent to people increasing a 40% increase in sales and turnover for that particular factory. So what that means is sustainable long-term savings are key and not just short-term savings. So invest in the long term, because that will drive the profitability. And their observation is that world-class OEE is 90%. The best in class that an Aberdeen study has seen is around 89%, but here's the kicker, that typically most of us in the UK, US and Western European companies operate at around 50%. So there's a significant opportunity around improving OEE, part of which is unplanned downtime and around maintenance. So what DMS do is they look and monitor around a machinery's DNA. They can look inside, exposing this hidden factory of what it is that explains how this machine is and how it's working when it's working efficiently. And they use temperature, vibration, oil condition, motor load. All of these are indicators of the health of the machine. And they've been generating this data since 2005. So again, this is not new, but what's changing as we go through the period of what they're doing on their iterations is the technology to achieve the same end is changing and the price point. So where they had Machine Guard, which was wireless comms and standalone software triggering locally, they're now moving to what they call Machine Guard, which will be Machine Guard 4, which is using Bluetooth sensors and a new web-based portal based on InVMA's Asset Minder. This is their current web portal, which they're using remotely to monitor and manage some of their customers' sites, to provide reliability assurance around. And you can start to see where you see asset in the graph below, where you can start to see an asset going out of kilter, not moving versus its control lines, maybe the odd peak outside of its SPC lines, but you start to see a trend which says that actually this might need some investigation. They're moving from that to monitoring systems where we're doing full Fourier transform analysis and really understanding or predicting the components that are affected by that. One of the problems with this sort of stuff is that if you've got aging or old machines, is that it's the retrofit cost. So with the technology and the price point starting to collapse now, you can get ATEX certified Bluetooth accelerometers connecting through a Dell gateway and connect to DMS's Machine Guard 3 on Asset Minder. This is due for launch in this quarter. And what that will enable us all to do is to do this spectral analysis, but it significantly reduces the retrofit cost of providing this assurance around a particular item. And with the cost of breakdown being so significant, this makes it quite attractive for a customer to be able to, a company to be able to do this across their manufacturing facility, and it immediately changes the model from someone in a van coming out to do, an annual or a monthly or a quarterly check of machines and machine vibration, being able to remove that need, install it locally, and then actually make the point. Make savings or changes or plan maintenance at a point when it's not catastrophic, and it's the cost of servicing will be significantly lower. That's the plan, and that's what these things enable you to do. So many companies are very successful with the sort of PTC's innovation platform ThingWorks, which is used across these, right the way from medical devices in the service area through to other manufacturing facilities, etc. To other manufacturing facilities. That's happened quite across the piece, but right the way from even just exposing OEE and downtime from across different factories, through to work instructions and helping people on service, through to work instructions actually on the line themselves being presented through AR. So that's what the technology enables you to do. But the real question then is, how do you go about this? Because it's a bit like, I guess it's a bit like tomato ketchup. It's kind of good with every meal, but well, nearly every meal. But what it enables you to do though is to start to say to yourself, right, okay, we've got hundreds of ideas and opportunities that we could use a platform like this to enable us to do. Where do we start? So what we suggest is you start by getting those ideas and opportunities and needs together. And because you've got a platform, you can pick ones, drop them through, build a backlog, design, have a little design session with the team, say what they want. You can then create you then identify which ones you actually want to go ahead with, and then you execute them in sprints. And then as you learn, you add more. And the point here is to focus on the easier, most valuable ones first, using a platform, so that it becomes very quickly, it becomes self-funding. So the idea is, excuse me, the idea is you get a product backlog of all the things that you want to change. You then say, this is the sprint that we want to do. You go and do that over a week to 2 weeks, and then you ship and add the data that's being presented to the user so that he or she starts to see the difference. This helps with adoption because people aren't faced with learning a big new system, but it also means it's focused on the stuff that they've said is of value and you've delivered quickly, and it builds credibility around the digital initiative that you're doing. And the consequence of that is your resource that you invest in there remains pretty flat, but actually you start to get value quickly, and then very quickly after a couple of 3 sprints, you're in a self-funding position where people are starting to see the benefits, and that's how we suggest that you would approach that sort of thing. So that's that. So basically, I hope in the last sort of half hour or so, I've taken you through what is the hidden factory. So just explored some of those things around, what is causing the waste. Explained a little bit about why we have the problem of the hidden factory around the ISA 95 model, where everything's around process versus the view that people need to see it across process. The fact that there are disparate systems across a manufacturing facility, but also each manufacturing facility is different. Hopefully I've exposed you a little bit to some of the technologies that are coming along, and particularly these industrial innovation platform like ThingWorks, which is enabling you to glue what you already have into something that's much more robust, and also shown you a way by which other people have started to use these types of innovation platforms to improve their services to customers, but also hopefully you start to see how, as a potential customer yourself, you will see how that could help your facility. And then finally, just suggested to you that a way to do that is to break it up into small chunks. What I'm going to ask now is for Steve Bramley just to take us a step up a bit and talk about a study that's happening and saying, well, why in the UK, is this, what are the barriers to all of this in the UK, and specifically to SMEs and mid-sized companies to adopting this type of technology? So Steve, over to you.
Thank you very much, John. Yes, so I'd like to zoom out from John's very excellent examples of the technology and some of the opportunities and how that might work, and sort of go out to a level where we look at what is happening in the world of associations and governments to try and help companies start their journey onto adoption of this technology, and what barriers in the way, and what solutions we might be coming up with, and how we might help you to engage with companies like in VMA. So very small introduction to Gambia for those who may not have heard of us. So we are a trade association. We represent the instrumentation, control and automation and laboratory technology industries in the UK. So I'm just waiting for the next slide to come along. It might be a slight delay. And as an organisation, we have roughly 200 members. They are in the automation and instrumentation field. Quite a large industry overall, 7 billion, about half of which is exported, 40,000 employees. And so you can see that we represent quite a number of companies there. Just about Gambia, we have 4 sectors: industrial automation, so factory automation and discrete manufacturing, a lot of what we're talking about here today, but also process instrumentation and control, so the continuous processing of oil, gas, water, etc., as well as test and measurement equipment and laboratory technology equipment. And some of the services we provide circle around 4 main things: market data and analysis on behalf of our members, technical regulation and standards. We're shaping and influencing that. Representation to government, lobbying, etc., as well as communication, exactly what we're doing today, helping to spread the message. So on to subject that I'd like to talk to you about, which is what is government doing and what is industry doing in terms of industry bodies, and how can we partner together to help push the UK forward. So a while back in 2017, the Industrial Digitalization Review was kicked off. It was commissioned by government, by the Department for Business, Energy and Industrial Strategy. And you can see there's over 20 organisations involved, Gambia being one of them, but also you'll see some automation companies in there. You'll see some universities, some government bodies, and some other companies that you might not necessarily associate directly with industrial digitalisation, but are interested. And the point really from government was to say that industry, tell us what it is that the government can do and how industry and government can partner to try and really get on this journey of industrial digitalisation. So the scope covers a lot of the technology that John discussed and other technology as well, but I won't read the entire list out, but you can see on the screen there, it's things like robotics, automation, industrial Internet of Things, as well as big data. So it covers a very broad range of digital technologies, all of which impact on the manufacturing environment. And the initial digitalisation review came up with some findings, and really these findings showed the need for some work between government and industry. The first one, investment levels. Over 3/4 of the businesses surveyed were looking to invest in digital technologies the next 3 years, and similar amount were also very motivated in terms of either cost reduction to try and make their businesses more effective, or looking for new revenue streams, so growth. And these are two very key drivers behind why a company might want to invest in digital technology. However, only 50% claim to have enough knowledge to be able to implement such technologies, and less than 10% believe they had the skills in place to be able to do that, with 80% believing that government had a strong responsibility in this area. And I think that's something really key for a lot of businesses is there's a skills gap in engineering and science and in general, and so being able to have the skills to take advantage of some of these technologies was a challenge. So this slide's very busy. I don't expect everyone to read all of it, but this is the structure of the Industrial Digitalisation Review. You'll see at the top the Secretary of State, Greg Clark, was the driver of all of this, that he chaired everything. There was a number of vertical segments. You'll see things like food and drink and aerospace and pharma, etc. And again, going across, you'll see the horizontal themes, looking at the skills problem, looking at the regulatory environment, looking at the barriers and delivery mechanisms, which is what I'm going to go on to talk to you about in a minute, as well as things like benchmarking and quantifying how many jobs are created through this technology. So Gambia was involved in 3 of these. The latter one in job creation, also electro-technical industry, and as I'll go on to speak about the barriers and the delivery mechanisms. So an initial survey also carried out looked at some of the barriers and the reasons why we might struggle sometimes to have high adoption levels. The number one that came out on the survey for most companies was culture and attitude. So attitude to risk, attitude to long-term planning, being able to accept failures and build that into your sort of experimenting, risk aversion, which is quite clear, especially when you have any kind of political or economic uncertainty, which we've certainly had, and openness to collaboration. So these are things that we feel both industry and government could work together on. Secondly, skills comes out every time, and not just skills in the technical skills, but also skills in leadership and management. And again, government policy probably has a lot of influence on skills right the way from schooling through apprenticeships and universities. And finally, the third largest area of concern in terms of barriers to take up for innovation and adoption. So where do I get trusted advice from? How do I know that this technology is the right thing for me? How can I look at innovation models? Can I see where this is already in practice? Can I see a company like mine where this has been put in place? and agility. Is I've got the ability to do this at scale? Can I do it in trials? Can I do it on one particular line? Can I make my business more agile by putting this technology in? So these are the questions raised. Ultimately, at the end of the study, a report was issued. It was called the Made Smarter report. You may have seen it. It's 200 pages. It's quite a long read, so I'll try and pick out some of the highlights here. This was published right at the end of 2017, and of course, we're moving towards the end of 2018. So what I'll do is go through some of the recommendations of this report and then see where we are as to what's been implemented so far. So top level was from the Made Smarter review: if all the recommendations were taken up, what could be achieved? Economically, a 455 billion boost to the economy, all through manufacturing. So the idea is that to make the manufacturing a greater contribution to the GDP in the UK. That's equivalent of a 3% sector growth year on year, which is a significant enough growth to really boost manufacturing in the UK, create jobs. 175,000 net jobs created, and there's a nuance there in terms of some jobs get displaced, of course, but overall, almost all technology will create net increasing jobs. And an environmental improvement as well, which is a key government target, a 4.5% improvement in CO2 emissions. So this report spoke to government about some key targets, both for the economy and the environment. Focused on three main areas, no surprises because these have been covered earlier in what we said as the barriers, but leadership, how do we generate a more ambitious, informed and focused leadership, and how does government support business to feel like it can be more ambitious without risking the farm? Adoption, how do we improve the adoption of technology? How do we make it easier for companies to engage with technology, especially across the whole supply chains and especially at the small and medium enterprise level of businesses? And finally, innovation. How do we get innovation, not just the products and the technology innovation, but the use cases? How do we get innovative use of this technology to really change businesses? So, a bit about adoption. We can see there's a graph that shows the size of the manufacturing industries in four of the top four European countries in manufacturing. So Germany, by far and away the largest there at 439 billion, and France, Italy and UK all roughly in the same ballpark. So German manufacturing industry almost 3 times larger than the UK. But when we look at what the German industry is investing in digital technology and automation, it's investing almost 7 times more than the UK. And that really shows in terms of the German productivity, the German economy, and also German employment figures. We can see there the UK is quite far behind Italy too, and below France. So of those 4 countries, we are the lowest levels of adoption rates. And that's something, again, I think the government can play a key role in helping with removing some of the barriers. So if we look at some of the barriers to adoption, skills comes out really top, and a number of aspects of skills. So first of all, shortage of engineering skills in general. We already are living through a shortage of engineering skills, not enough people coming through the education system or into an engineering vocational role. We also have the reskilling of an aging workforce. That's a critical issue whereby something like 50% of the engineering and technology workforce are over 55, and due to retire then in the next 10 years, and that creates an enormous problem in terms of reskilling. We've also got no real national coordination on policy and skills. It tends to be regional, tends to be by industry, and depending where a company is how much help they can get with this issue. In the innovation world, again, I think the support environment can be quite confusing, knowing which organisations to go to for trusted advice. Again, varies by region. Again, SMEs are very under-supported, and yet 99% of companies in the UK are SMEs, small medium enterprises. And again, no national coordination. There are regionals, some regions better than others at giving advice and funding, but again, it can be quite a minefield in trying to navigate your way through that. Similarly, in the culture side of things, of course, business is going to be risk averse whenever there's any kind of economic and political uncertainty. And we'd have to say that with Brexit, we've probably got the most political uncertainty we've had in many people's lifetime. So there's definitely the ability for the government to create some kind of environment by which making investments becomes less risky. Also, some form of perhaps national branding and campaigning, which can help to raise awareness and get people interested, not just again from investment, but also back to the skills. If you can make it an interesting and vibrant topic, the technology argument could start to really interest young people back into this profession. And again, common theme: no national coordination and on collaboration and risk sharing. And I'll come on to what some of the solutions might be to these things. So, recommendations from the Made Smarter report. So this is the ask of government and also the proposal from industry to say, this is how we think we can partner together and solve this problem. The first one is to create a more visible and effective digital ecosystem. Now, that's a bit of a buzzword sentence, but what it really means is that to accelerate the innovation and diffusion of IDTs, and IDTs here is an acronym for Industrial Digitalization Technology. Really what we're looking for is to be able to create a national infrastructure whereby, a bit like the Catapults, which some of you may have engaged with, but have demonstrators, have places where people can go and have a look at the technology, but not just look at it, but use it, perhaps adapt it to their needs, try and find solutions to their problems, demonstrate scale, demonstrate it down at the SME level, whereby it not necessarily is going to be something that's a massive capital outlay, or it's not necessarily going to be a barrier in terms of access to these things. And then also the ability to start people on their journey, give them some advice. And another part of doing that, excuse me while I wait for the next part of the slide to come up, having a bit of a delay. So the next part of that is to upskill 1 million industrial workers. Mentioned it earlier, and I think a real key part of technology adoption is, one, having the skills in the business, and two, taking the workforce along with the plans to bring this technology into the workspace. In many cases, that technology is augmenting, it's helping people do their job better, giving them more information, giving their decisions. I think John gave quite a few good examples of that in his part of the presentation. And then really inspiring the next generations of leadership and have some branding which helps to get behind an initiative, rather than leave this all to uncoordinated and regional level, have some sort of national scheme which will help to improve adoption rates. So address the key barriers, it sort of wraps up the whole thing, and drive the adoption of industrial digital technology. So some specific actions just to bring out of this that we particularly support. There's a lot of recommendations in this report, as you might imagine, in something that's 200 pages long, but the ones that we particularly feel are important. First of all, the Made Smarter Commission. So this is a group of leaders who are being chosen across industry and government to come together and really drive all of these initiatives and make sure that they happen. That is imminent, and when I say imminent, really this week or next week, I've been told that the members of that commission will be announced. And from that point, that's really where the activity will start. It's been a long time coming. It's been a bit frustrating that government's perhaps been a little distracted with the whole issue of the relationship with the European Union. But this will happen, and therefore expect to see some news on this very soon. The other one that we really support is this industry demonstrators, and I think in our own terms we've used living laboratories rather than demonstrators. I think demonstrators seems a bit passive, and really what this is trying to encompass is a facility or a network of facilities up and down the country, housed in neutral venues like Catapults, like universities and other research bodies, whereby you could either go locally or industry specific to these facilities and use them, train people on them, part of the upskilling, part of the apprenticeship training could all be done on these demonstrators or these living laboratories. The ability to test out products, test out solutions, test out connectivity, proof of concept. And really, this is back to the sharing of the risk, the ability to try these things away from your own production line. You don't have to close things down or stop production, and you can go away. It's also a driver of collaboration, much easier to work on a demonstrator, for example, in a group of other companies, not necessarily competitors, but perhaps part of the supply chain, for example. Digital innovation hubs, I think, are a really key, again, part of the infrastructure of helping drive adoption. And the idea here is it's a place you can go for advice, start your journey, get signposted as to the next places that you can go to. There should be some expertise. Again, it's government funded, neutral, it's not a commercial advice. And of course, there's plenty of vendors out there who will be able to provide the solutions. But the Digital Innovation Hub is really about having a set of funded experts who can perhaps come into your business, have a look at what the priorities might be in terms of what solutions you're trying to find, or what problems you're trying to find solutions to, etc. And then a national adoption program, really trying to accelerate the take-up of industrial digital technology. It's a bit like a snowball. Once you start getting this going, it starts to spread through supply chains, it starts to spread through numbers of companies, it starts to increase the skill level, and it's a sort of a self-fulfilling prophecy, really. Skills is really important, and part of the Motor Smarter Commission needs to be driving what are the future skills needs and what are the current skills needs, and what are the solutions to doing that. And finally, standards. I think sometimes these things get overlooked, but actually standards are a key part of making sure that we have harmonized technology that talks to each other, that you have interoperability. So it's quite an important part of underpinning the future. So that finishes my part. I think would sum it all up as well as all the vendors out there who've got lots of really good solutions and lots of really good technology. There is some help on the way in terms of support, signposting, and helping you to get onto the journey. I'll hand back over to you, John. Thank you.
Thanks very much, Steve. So really, what we've heard about so far is what we've done is consolidated what we know about the hidden factory. Hopefully we've understood, you've had a chance to understand some of the technologies, and we shared with you some others' experience, but also consider some of the adoption challenges, for your own situation. But I think what Steve certainly got across there, and thank you, Steve, is to say a lot of help is out there already in terms of innovation funding, etc., tax credits, etc. But and that help is coming. So yeah, thanks very much, Agatha. So if anyone's got any questions, please, let's remove those faces, or my face particularly. And if anyone's got any questions, please, if you look in the questions element in your control panel, you can start to ask questions there. Just looking down now to see what questions have been asked. Okay. So we've got one really here, Steve, which is about funding of the technology. Touched on a little bit myself then, but have you got any advice, etc., for people that are looking to look to do this sort of project and how they could potentially fund it?
Yes, there are a couple of routes that could be done right now. That the whole Motor Smarter Commission is going to also look at how projects are funded, but there's two main vehicles that are currently both government funded. One is Innovate UK, which is it comes under the Department for Business in the government, and it's now in an organisation called UKRI for Research and Innovation, and they run competitions, and they run a number of different styles of competitions, which all have funding attached, where either it's looking to solve a particular solution, looking for a solution to solve a particular problem, or it's looking to boost innovation in a specific industry. So it could be an end user industry like food and drink or pharma. They also do some regional ones, and they also do some themed around things like cybersecurity or productivity or energy efficiency. So it's always worth looking and perhaps subscribing to the Innovate UK newsletter, which they're quite there's quite a lot of calls out there for these competitions and funding activities. The second one then is the high value manufacturing Catapults, which is a series of support centres in the UK, which their idea is to really bridge the gap between having a blue sky idea at, say, perhaps university research level and turning it into something commercialised. And whilst they might not give specific funding, what they can give is resources and support to help with projects.
Yeah, I mean, if I can add to that, Steve, as well, we've certainly found we work with universities like Bristol and Birmingham and Birmingham City University, Lancaster, etc., and they're providing certainly SMEs and local firms with quite high skilled technical support, which is partly funded from the university as part of a master's program, for example, but also from local funding as well to start to drive innovation locally. So, you know, getting close or tied up to a local university also helps with that skills gap, and you start to get a chance to see the young people that are coming through into industry that have got a heart and an interest, and get them working on one of your problems. You know, we've certainly seen that really helpful, and they get access as well as universities to a lot of software, a lot of hardware that obviously vendors are offering them so that they can prototype these types of solutions for you. So that's the other place to sort of go and look, and obviously talk to vendors like InVMA as well. But and seriously, locally, there's a lot of opportunity there. Agatha, have you got any more questions come through?
Apologies, I was on mute. Yes, we've got. What tangible savings can I expect from this technology? Someone asked.
I guess it depends on how bad you are and where you start from, I guess. But we're finding that the key, just talking as InVMA, the key savings that we're finding at the moment are around overall line availability, part of overall equipment effectiveness. So that's avoiding unplanned downtime, etc., is the main saving. But out of that as well is also coming a consequence around operator efficiency and effectiveness and operator error around the augmented reality version, particularly in high value manufacturing, where you know, it's all about quality, low volume, high value manufacturing in the AR side. The other elements of savings come from AR also is in the training element. So being able to train someone using digital ways, a bit like they're in a game rather than on the actual production line themselves, particularly is about site understanding and where they've got to be in site, etc. Does save people quite a lot of money, right the way through to just having the understanding and the availability of the data, so that instead of waiting for your monthly report that told you how bad you did, you're actually getting data immediately that tells you that you're going to have a bad monthly report unless you do something right now. So I'm not going to answer the question, you know, but the answer is that the value, look at each individual value proposition that you're doing, look at the business case and ask yourself the question, if I could avoid downtime of 1 hour on this line, what would it cost? What would it save me? And you know, and really start from the metrics end. I don't know, Steve, if you've got anything to add to that from your vast experience.
Yeah, I think it's very difficult to give a say a percentage saving which could be achieved, because as you said, it entirely depends on the business. But we've seen lots and lots of examples where the savings are not necessarily always in the area you might have started from. So whilst productivity is quite often a driver, or reduction of cost, for example, that can be done in a number of ways. So quality, for example, less rejects, less scrap, starts to save significant amounts of money. Again, depends on the value of the product you're making. In high value products, reducing scrap and rework can make a significant improvement. Energy efficiency is often overlooked as one of the key benefits of automation, especially if you're controlling anything around pumps, fans, and compressors. And significant savings can be made there. I've seen lots of examples where 50, 60, 70% of energy saving, and energy becomes an increasingly high cost in some businesses. And then sometimes just accuracy, repeatability, the ability to make a product more to greater precision than a competitor perhaps will start to win more business and increase reputation. So there's lots of measurables that are just outside the straight productivity or pounds and pence saving that's due to this technology. Thank you.
That's great. Okay, conscious of time, Agatha, have we got any more questions?
I'm afraid that's it for now, unless someone else has any more questions. I would like to just remind everyone that you will receive the recording of this session in a follow-up email. And also you'll be able to download your HBR articles that John mentioned earlier in a follow-up email as well. So yes, thank you very much, John, and thank you very much, Steve. And if that's everything, we can just wrap up. Thank you everyone for attending.
Thank you, Agatha. Bye-bye.